Any sound? Okay, perfect. How's it going? Everyone like completely sick of TechEd? Last day, like let's go home. No? No one? Okay. Well, anyway, thank you very much for, hey, can we get the clock started? Thank you very much for coming. Last day, lunch is served in like 15 minutes, so I'm expecting like half of you to just walk out the door as soon as 1:15 comes around. So I won't blame you. It's okay. All right, this is Identify and Fix Performance Problems with Visual Studio 2012 Ultimate. I'm Benjamin Day. I am based in Cambridge, Massachusetts, and I do TFS consulting and Scrum consulting, architecture, Azure stuff. I used to do a lot of stuff with Silverlight, but I don't do so much with Silverlight anymore. I'm an MVP for Visual Studio ALM, speak at a lot of conferences, write articles, all that kind of fun stuff. And I also am a certified trainer via scrum.org, teach 2 different classes for Scrum. One is called Professional Scrum Developer, which is a 5-day for doing Team Foundation Server with Scrum, and then Professional Scrum Foundations, which is a 2-day class on just how to do Scrum with your team. benday.com, benday@benday.com is my email address, and @benday is my Twitter account. So feel free to follow me. I have the absolute most boring Twitter account of all time. I pretty much just retweet what other people say. So if you say nice things about me on this conference talk, I will retweet you. How's that? Does that sound like a good bargain? So how many of you have heard of scrum.org? Perfect. Okay. And for the rest of you, just a quick little thing on scrum.org. They're looking at improving the profession of software development. It's founded by Ken Schwaber. Ken Schwaber invented Scrum, and they've got a bunch of classes. So if you're interested in learning more about Scrum, go to their website. And before I fully kick off, I want to thank my technical content reviewers, Jerry Chu from Microsoft and also Dennis Bass from Microsoft. They helped out a lot, made this talk an awful lot better. So the agenda for today is I'm going to go through what the basics are of web performance tests, load tests, talk about what a load test rig is, and then we're going to get into fixing some code performance problems using Performance Explorer. And what we're going to do is we're going to use an existing application, find the performance problems, recreate the performance problems, and fix them. Okay? So the purpose of load testing is, well, a lot of different reasons you'd actually do it, but it's to identify what your application can actually do. So a couple different reasons you'd want to do it. One is to explore. So you want to see, okay, well, what can the application actually do? Does it handle 100 simultaneous users? 1,000? 100,000? Maybe you want to find that out. Or maybe you have a contract that says you have to support 100,000 simultaneous users with 5-second or less response time. You got to verify that that's actually accurate, actually happening before you release to production. Other times you just want to see, okay, what is the absolute maximum that we can support on this application, on this hardware? So just keep throwing users at your application until it can't take anymore. That's your maximum number of users. So that's finding the limits. And then sometimes you just want to kill your application. You want to crush it. So you want to throw as many users as the application will possibly take, and then just keep adding more users. So the idea there is you want to say, okay, well, when things are really going bad in the application, does the app still do okay? Or does it suddenly start serving everyone's credit card numbers up and the administrator password for the box, and it just gives you a remote desktop login and everything's all finished? Yeah, hopefully that doesn't happen, but you know, sometimes you want to verify that. All right. So since I am a Microsoft MVP for Visual Studio ALM, ALM equals Application Lifecycle Management, it means that I walk around and I go to talk to customers and I tell them that they're doing everything they do wrong. Okay? And I'm not sure if the phrase eat your vegetables translates perfectly, but eating your vegetables means You're telling, it's like when you're like a little kid. You got a 5-year-old kid, he hates Brussels sprouts, hates broccoli or something. And you know it's good for them, and you're like, you got to eat your broccoli. And they're like, I don't like broccoli. Eat it anyway. So that's what this slide is about. So what you should do if you're doing load testing is you should start load testing right at the very beginning. So as soon as you have something that could be load tested, start load testing it. And the reason you're going to do that is you're hopefully going to catch your performance problems early before they're really a big deal. And you're going to watch for trends, okay? So if the application is performing just fine today, and then 2 days later, now performance has gone off a cliff, you probably know that sometime in the last 2 days something happened. You're going to try to fix that. So rather than waiting, so our performance is good, we're going to wait. We're going to run our load tests in 6 months from now. And then you have to guess at what happened in those 6 months that caused your performance problems. So cheaper to fix early. And then actually the important thing here is if you don't plan for performance, why should you expect to have a high-performance application? Okay, so you got to look at load testing. You got to examine your application. And if it's not performing well, you got to fix it as soon as possible. Plan for performance. So you've probably all seen a graph that looks like this. This is based on no data whatsoever. I completely made it up. It's garbage. But you all recognize the general slope. So early in your project, really easy to fix stuff. A little bit further, it gets a little bit more expensive. When you're almost ready to ship, it starts to get expensive. And then when it's out the door, it's going to cost you $1 billion to get your application performance fixed. So it's cheaper to fix early, and you probably should. Hopefully I'm not going to cough through the entire thing. How am I doing so far? Am I talking too fast? Too slow? Thumbs up? Okay. If I start to, if I'm too boring, just let me know. I'll try to tell more stories or something. All right, so you should write load tests and run load tests early, but how many of you actually do that? Okay, early? That is maybe 2% of the audience, tops. You guys are amazing. That is generally not how it works. Actually, I'm surprised that even that many people said, yep, we load test early. I don't believe you. I think you're probably lying. Developers are liars. We always say, hey, is that task done? Yep. All right. So we all know we should test early. You don't. And this talk is basically dedicated for you. Dedicated to the 99% of everyone in the universe that works wrong. So the idea here is that you've figured out that you have performance problems, and now you're like, what do we do about it? All right. And the inspiration for this talk is an actual customer engagement. So a United States federal agency spent about 3 years, 6 years, depending on who you talk to, developing this application. They had unbelievable amounts of hardware. Their data center was beautiful. And they released their app into production, and everything just exploded. So they released it. They hired me and a couple other people to come in and create some load tests. And we figured out that on this unbelievable data center, they were doing 20 simultaneous users. 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's it. That's it. Thousands and thousands of dollars worth of hardware, awesome hardware, 20. Like, high five. Yeah. Makes me feel good about paying my taxes. So we went in here, and what I'm going to be walking you through in this talk is exactly the process that I did for them to fix their performance problems. And we went from 20 simultaneous users to about 4,000. And we reduced the amount of hardware they had to dedicate. So the tools that I'm going to be talking through are in the Ultimate SKU and the Premium SKU. So web performance test, load test, and load test rigs are in Ultimate, and then the profiling tools and the performance wizard are in Visual Studio Premium. All right, so I'm going to give you a tour of the application that I'm going to be working with. So let's come in here and let's run this guy. Okay, and this application is the content management system that used to run my website. So I've since moved over to WordPress, but we've got folders inside the application. By the way, I'm a huge fan of Champagne. Anyone from Champagne region in France? No one? Okay. I was ready for you to be my best friend ever. Can I come visit? Do you know any grower champagnes? I also like cheese. So I've got folders along this part here, and I've got pages inside those folders. So basically, it's a database-driven website engine. And inside of this, I've got, if I go to the admin page, if I go to administrator, this should give me the editor that allows me to start editing these folders. So if I drill into one of the folders, it shows me the pages that are in here. I can come into the pages, edit them, save them, updates the site automatically. Make sense to everybody? Pretty straightforward? Okay, so that's the application. So we've pushed it out to production, and everything just, man, the heavens open, and it's raining, and it's terrible. Our users are calling up. They're like, wow, your website sucks. I cannot believe how bad this is. I'm getting errors like about every 5th page as I click through. What's going on? Super, super slow, too. And, of course, your boss is beyond angry. She's coming into your office. It's like, you're fired if you do not fix this in the next 24 hours. It's going to take more than 24 hours, but you say, okay, boss, whatever. That was another problem on that customer. So you're staring at this, and you're bringing it up on your machine, and like, works fine on my box, right? How often does that happen? All the time, right? That's called the no repro problem. I can't reproduce this bug. So you're going through on the development server, you're going on the QA server, works fine. You go to the production server, and you're like, it's a little slow, but I don't really see it. And you're like, well, what's going on? Doesn't make any sense. So you think about it, and you're like, well, what's the only difference between our testing we've done on the QA server and our production machine? 10,000, 50,000 users, maybe? Little difference, just a tiny one. So you figure out that perhaps this application is just dying once a lot of users start hitting it. So you figure out, okay, well, in order to actually reproduce this problem, we've got to go find a way to simulate users so we can see what's going on. So you come up with this plan. 6 steps. This is how we're going to fix our application and make it awesome. So first off, what we're going to do is we're going to script out a bunch of user activity using web performance tests. So let's hop into that first. So a web performance test is a type of test inside of Visual Studio 2012 Ultimate. And the idea here is it's going to simulate HTTP traffic, so simulate web traffic against an application. So if you've got an ASP.NET application, works pretty well with that. You record yourself going through your application. It turns into a web test, and you can play it back against that server, and you've simulated a user. And what you're going to eventually do is you're going to use those recordings of yourself simulating a user, and you're going to turn them into load tests eventually. And load tests will just simulate a lot of users doing that same thing. So how many of you have ever used a web performance test? Okay, that's pretty good. So here's a tip. if you get into doing web performance tests, record them like they're user stories. So a user story, also known in Scrum as a product backlog item, so it reads something like that. As an administrator, I need to search for a person by username so that I can deactivate that person's account. So it's a very specific case through your application. So when you record that web test, try to do one thing. So don't do multiple things in one recording. And the reason why is it keeps your suite really organized. And if your test suite is organized, later on when you go to run this as a load test and you see, okay, well, we've got 20 different web tests, but this one's dying, now you know which use case to actually optimize for. Okay? So it keeps it organized so you can find and localize the performance problems, hopefully. All right, so let's go in and create a web test. So let me just quickly rerun my application. And I'm going to copy my starting URL into the clipboard, and then we're going to come into our solution. So if you wanted to create a web performance test from scratch, you're going to go into your solution, say Add, New Project, and under Test, you've got the Web Performance and Load Test project type. So that's new for 2012. So in 2010, 2008, 2005, it was just a regular unit test project. But as you probably heard, the unit test framework has changed a lot. So if you want to do web performance tests, you're going to use that project type. So you choose that project type, creates a new project, and you're off and running. So I've already created one over here. And let's say that I want to create a new web performance test. I'm going to right-click on the project, select Add, and choose Web Performance Test. Yeah, come on. So if we click that, that's going to pop open. Yes, I want to enable that add-on. That's going to pop open Internet Explorer, and you're going to get this web test recorder panel inside of Internet Explorer. So what you'll notice is that as I navigate through the application, it's recording the steps that I did in this window. So if I click on this folder, it records another step. If I click on a page, it does that. And it's recording the stuff that I've done. So when I'm finished simulating what I wanted to do, I'll click Stop, and that comes into the project as a web test. So you see we've got those same steps that are showing up here, and that becomes this, we'll be able to later on play that back so that we can simulate the same user activity against the server. So right now it's detecting dynamic parameters. So if you're using ASP.NET session IDs that are on the query string, it'll pick that up and automatically fix it. Sometimes takes a little while. So it takes longer. There's something about this dialog. It knows how many people are looking at the screen and makes it run slower the more people there are. Yeah, it's good. Come on. This usually takes about 2 seconds. Come on, you can do it. Oh, these parameters did not even detect any. Come on. Okay, round of applause for that dialogue taking forever. Yay. All right. Man. Is this being recorded? I hope not, because I'm going to tell a story. So I taught a class at Microsoft in Redmond, 2 or 3 years ago, right before TFS 2010 and Visual Studio 2010 came out. And we're in a classroom of like 30 people, and no one could get Visual Studio to run for more than about 30 seconds. Like they'd open it up and it would just crash. And at some point, one of the students were like, hey, I got it up, it's running, and it's not crashing. And I was like, that's awesome. And I said, round of applause for Visual Studio not crashing. And everyone applauded. And the guy that runs the Visual Studio team was in the back row. And at the next break, he came up and he's like, you really shouldn't say that in front of audiences. And I was like, okay, I know. I won't say that when you're around ever again. And he said, no, you really shouldn't say that ever. And I'm like, okay, good. So I just told that story in front of all of you. So don't you feel lucky? I'm never going to get another penny of work from Microsoft again. Okay, so I recorded myself going through and doing that. And now I've got these steps inside my web test. So if I drill in, it's recorded stuff like my query string parameters. So we got this one right here. So item ID 362, whatever that meant. So when it goes and we play this back, it'll send that back up to the server. And if we go through the other ones, we'll see that they have similar stuff in them. And if I had HTTP post activity, it would go in there as well. So if I want to run this, I click on, surprise, surprise, the Run Test button. Okay? And that will replay this against the server. Hopefully. I swear to God it'll actually work. Okay, pretend it worked. All right, moving on. So that was creating a basic web test. We'll come back to the results of that in a second. So that one was not especially interesting. It recorded the IDs that we it recorded the same IDs that we used when we're browsing the site. So remember it said item ID equals 362. So when we play that back, it'll always say item ID 362. So thankfully there are some features that let us do something more interesting. So one is called parameterization, and the other one is data-driven tests. So what we can do is for pretty much anything inside of those web tests, we can parameterize it and say, okay, don't use the hard-coded value, use a value from a data set. Okay, so in this case, we can hook it up to an OLEDB provider, we can hook it up to a comma-separated value file or an XML file, and we can pull those values in, and what we can do is we can simulate users doing a very similar activity, but with slightly different data. All right? So that makes a much better test, much more comprehensive, and it does something actually useful. So let's go in and let's look at some of those tests that I've already created. Man, it's still going. Okay. So what it's doing right now is it's showing you the performance problems that I've created in my app on purpose. So inside my web tests project, I have got, let me close this and open it up in the designer. Here we go. Okay. So this one simulates me going through and browsing my site just by clicking. So what I'm trying to do is I'm trying to think, okay, if I'm going to recreate the performance problems in my application, I need to record users doing basically the same stuff that I think they'll be doing in production. So in this case, I'm going to go through, I'm going to record myself clicking through the application, browsing the site, and I'm going to get this. So if we come through here, let's see. Oop, I opened the wrong test. Browse the site by clicking data-driven. So one of the things that I've done here is that I've added a data source. So if we drill in, I've got a data source that will go and select from my web page table, and it will just bring back all the data. And it'll cycle through every ID in that table and play it back. And those IDs, if we drill into them, show up on the CMS web page. And what I can do is I can come up here and say, for this request, I don't want to use a hard-coded ID. I want to use a parameterized ID. So I can click on this guy and then come over to properties. And I've got my nice little designer here where I can drill through. Oops, that was not what I wanted to do. I can drill into my data source and pick, for example, I want to choose the ID property, the ID value, and it'll just automatically drop that in whenever we run the test. Let's fix that guy. All right. Another thing that it will do is it can also parameterize the web server. So let's say that you want to, the name of your server is localhost when it's running on your dev machine, but when you run these in your staging environment, you have a different server name. So that's a good case for where you'd want to parameterize that server. So you see we've got this guy right here, squiggle, squiggle, web server 1. That, when this test runs, gets replaced with this value down here. So there's something called test context parameters, and that allows you to put in name-value pairs that you can use in parameterized stuff throughout your test. Okay? So do you all see how that can start to become more interesting and build more interesting tests? Any questions right now? Okay. How am I doing so far? Anyone think I absolutely suck? No one? Awesome. Remember to fill out your reviews. Ben didn't suck. Okay. Moving on. So actually, let me go through. There's a couple more web tests that I've done. So I've created a couple tests. So we've got the one that navigates the site, pretends it's a user. I've also got one that will create new folders. So basically, I'm simulating not only users, but I'm simulating administrators using the site and editing the site. So I've got something that will create a new folder, create a new web page, and then edit an existing web page. So what I'm trying to think of is, what is the comprehensive list of user stories that I'm going to do in my application, and I'm going to record them, create them, play them back. Okay? And that's what I've got right here. All right, so next up, load tests. So we did step 1 already. So we went through and we recorded ourselves clicking through the application, doing something important. We've also probably gone in and edited the stuff we recorded to make it data-driven so that we've got a little bit better test, a little more comprehensive. Because it's probably not useful to play back the exact same user traffic for every single use case, right? Because you probably have like SQL caching and data caching and all that kind of stuff. You want to change the IDs so that it's not cacheable, or at least looks a little bit more like reality. So we record those web tests, and then we move on to step 2. Step 2, we want to figure out how do we actually create a whole lot of users. So those web performance tests, if we run them, it only does one user at a time. Not bad, but not really comprehensive. That's about the level of testing we probably did before we pushed into production and found out that, well, everything was broken. So with the load test, we simulate a lot more users. And the idea is you're going to use, instead of just one web test, you're going to use a whole bunch of web tests and simulate a whole bunch of users doing a bunch of different things all simultaneously. So getting into that place where you're creating a comprehensive test, so that the load that goes against your application looks like the load you'd see in real life. So you also can add unit tests to those load tests. So you don't have to only have web performance tests. Unit tests, regular, just plain old unit tests. And the idea there is that if you've got stuff that's not easily simulatable as a web page, or it isn't a web page, like for example, maybe you have a particular stored procedure call that you want to test, that's where you'd want to add unit tests. Question?
So the question is it possible to add loaded UI tests?
So coded UI tests?
Yeah.
Can you run coded UI tests from a load test?
Yeah. So it's very close. Why we need a new UI to record our performance test?
Ah. Coded UI test. Excellent question. So the question is, if we have coded UI tests, why do we need web performance tests as well? And the interesting thing is that when we run a web performance test, we only simulate the HTTP that goes by. So if you're doing coded UI tests, you have a user that's clicking the browser, and the browser is going up to the server. So this is really, really lightweight, and it's designed so that you can generate an awful lot of user traffic very easily. With coded UI tests, it's a lot harder to create a lot of traffic.
But coded UI test you can manipulate a particular story and assign to test management, for example.
Yep.
And it seems like a duplication work. We record it for performance and for functional testing.
So we should probably take this offline, but the short answer is that coded UI tests have a different purpose from web performance tests and load tests. So coded UI is really more of a QA, quality assurance thing. This is more of a verifying that your application performs thing. And the implementation under the surface is really quite different. Simulating 2,000 simultaneous users or 4,000 simultaneous users with coded UI tests is going to be ridiculously expensive. It's going to be close to impossible to do that. With this, very easy. We'll discuss it more after, if you want. All right. So why would you actually put a unit test inside a load test? Main reason here is probably WCF. So how many of you do WCF programming? Okay, lots of you. So using a web performance test, you could record yourself doing, let's say you had a Silverlight application. You open up the Silverlight app in the web test recorder, and as you drill through that application, it's going to record all the WCF calls you make back to the server. So you can record WCF calls and play them back. It works. But parameterizing them is really hard to do. So because it's a big, giant chunk of XML, it's challenging to make that work. So if you have a WCF service, you really, especially if it's Silverlight, you really don't care about the Silverlight part. You only care about testing the WCF. Service-oriented architecture. So if you're in a service-oriented architecture configuration, what you're probably going to want to do is just, right-click, add service reference, connect to your WCF service, create the proxy in C#, just like you do, and then you're going to create a unit test that's going to use the service proxy, and you're going to have all that stuff done in C#. It's a lot easier that way, worlds easier that way, to make your WCF services do stuff that you want. So if you create unit tests that will exercise your WCF service, you can add that into your load test, and you're good to go. If you don't want to do it that way, there's a WCF load test plugin and SQL load test plugin on Codeplex. Those give you some tools that can make your life a little easier if you don't want to use unit tests. So let's create some load tests. So I'm going to say, hey kids, let's create some load tests, and you're going to say hooray. Ready? Hey kids, let's create some load tests. Hooray! Yeah. All right. So you actually are paying attention. Sweet. Sometimes when I do this presentation, I just have glassy stares. Especially the last day of the conference, you guys are amazingly attentive, because I know that when I'm on day 5 of a conference, which we all are actually, I'm like, no more .NET. I'm all set. Thank you. I'm going to watch TV for a little while. All right. So if you want to create a load test, you come into your web load test project, right-click, add load test. And that's going to bring up a dialog, a wizard, that'll walk you through the process of creating a load test. And since this is a Microsoft product, and this is a wizard created by Microsoft, the first page is always useless. So hit next. Now that I told you that, you're going to see it everywhere. Okay, so what it's going to ask you to do is it's going to ask you to create what's called a scenario. So a scenario is a grouping of tests that you want to group together, and that scenario has something called think time. So as I went through and recorded myself browsing the site, the delay between clicks got recorded. That's called think time. So if you're thinking about, let's say your mom clicking through an application on a website, she's going to click on it and be like, okay, next. Next. That's what you're doing here. You're simulating your mom being slow. A computer is going to go through and be like, dunk, 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 done, high five, let's go get a beer. So we have a couple different ways to deal with think time. So one is you always use the recorded version. So whatever you did when you clicked through, play it back with the same one. Or you can do some statistical distribution that it'll play with it and kind of mix it up a little bit. Make some a little slower, make some a little faster. That makes it a lot more like a real user. Or if you don't want to use think times, like if you just want to see how much load we can throw against our application, you'll say, do not use think times. All right? So I'm going to choose the default, hit next. And the next thing it's going to say is select a load pattern. So load pattern is how many users are going to be in your load test. So as it simulates users, how many are there going to be? So there's 3 different ways to simulate load. So one is constant. So it uses the same number at the beginning as at the end. So in this case, it would be 25 users. Or we can change it to step load. And step load will vary the number of users that are in the application. So we'll start off, in this case, with 10. And then every 10 seconds, we'll add another 10 users up until we have 200 simultaneous users. Okay? And then there's a third one, which is called goal-based. So what you can do is you can't do it through this UI, but you can do it through the editor. You can attach your load test to a particular performance counter in Windows, and it will just keep adding users until the performance counter hits a certain value. So let's say the performance counter is % processor utilization on SQL Server. Okay? You can bind to that perfmon counter in SQL Server, and when it hits 80%, stop adding users. But until it hits 80%, keep chucking users at it. Okay? Hit next. The next one, I find this to be unbelievably confusing. So there's a couple different ways of how the load test framework chooses which web tests to run and in which order, and which ones are actually happening. So you can see, based on the diagram here, that if we say, based on the total number of tests, it's just making sure we have the same number going again and again and again. And then we've got some that are based on the number of users. We've got some based on user pace, sequential test order. It would take me 45 minutes to describe this screen alone. So I am not going to do it. The documentation is really good. So most of the time, you're good with that default option. But if you want to change it, go look at the docs. There's a lot of different configuration options related to this screen alone. All right. So finally, we get to choose which tests we're actually going to have inside of our load test. So I'm going to choose these guys, hit OK. And now we've got the suite of web tests we created, and we have a distribution. So right now, they're all done equally. But let's think about what our application's really going to be like in production. In production, we're probably going to have an awful lot more people that are browsing the site than we are doing administrative stuff. So item 2, 3, and 4 are all administrators editing the site. Number 1 is users browsing the site. So let's say this is 75%. You drag that up, say that's 75%, and then the rest is some mix. So if we want to, we could play with that if we wanted to, but it has to add up to 100%. Choose that, click Next. We then have the ability to simulate different network speeds. So not all users are going to connect from your LAN. Some are going to connect over a 2800 baud modem, and you want to be able to emulate the pace of them using your application. So you can specify a mix on that stuff. I'm just going to choose LAN for today. And then we have the opportunity to simulate certain browser types. So you're thinking, wow, that's pretty cool. So the load test agents, the load test machines will simulate, they have Firefox 2 installed? I thought you couldn't run Firefox 2 side by side with Firefox 3. The answer is, you can't. So what this is actually doing is it's updating the user agent string in the header. Does that make sense for why I was answering the question the way I did? There's no real browser on the back end of these web tests. So what this is really for is it's for making sure, it's for tricking your application into behaving different ways depending on what the user agent actually is. Okay? It's always the same user agent. It's always the same client, but this is basically spoofing what the browser is supposed to be by adding those values in. So you can do some kind of a mix, like let's say, all right, we want to do 50% IE9, 50% IE10, and you're off and running. Next up is the perfmon counters. So this is where it becomes really important. This is like where the interesting stuff shows up. Because if you have load tests and you just run the load test and you see, wow, that case is really slow, you don't really know why, right? So what you really need to do is you want to find out, okay, well, is it slow because SQL Server is dying, or is it slow because there's a problem with the disks? Is it slow because the network card is bogged down? Are we out of memory? All these different questions, right? Do you all know what perfmon counters are? Anyone not know? Cool. That looks pretty good. So what you can do is in the load test, you say, okay, which computer do we want to monitor? So my computer here is called Borgomale. Anyone here from northern Italy? No one? Okay, I was ready for you to be my best friend too. I am friendless. Apparently no one likes me. No one wants to hang out with me. Oh, yeah, can I get an aw? Oh, yeah. I can just see it on my evaluations. Ben has no friends. Thanks, guys. You're the best. All right. So in this case, I'm going to choose which machines I'm going to monitor. So let's say I've got my web server, let's say, is Borgomale, and let's say I've got SQL Server 1 as my database server. So I'll say we're going to monitor, oops, that's not what I wanted. We're going to monitor this stuff on this machine, and we're going to monitor SQL Server on the SQL Server machine. So it allows us to say, okay, here are the perfmon counters I want to capture, and it's going to capture it in real time as we go, and it's going to graph everything against each other so we can see, okay, well, when we hit 150 users, that's when SQL Server fell over. I wonder what's going on there. Something like that. All right. Then we've got some other stuff about how the test warms up. We're just going to choose the defaults. And then we hit finish. And then it creates our load test. So if we drill in here, we've got the scenario we just created along with the test mix we created. So 75% are clicking the site. The rest are doing admin stuff. We've got the browser mix. We've got the load pattern we wanted here. We've got all the counter sets. We've got the names of the machines that we're going to be profiling for perfmon counters. And one of the things you don't get through the wizard, if you click on your test run settings, it automatically gets generated for you. we've got a bunch of stuff for SQL tracing. This is also really awesome. So if you set that up and you say, okay, what's this connection string to our database? Where are we going to log the profiler output? Have you seen the profiler in SQL Server? Yeah, okay. So it basically shows you all the traffic that's happening in SQL Server in real time. So if you populate this stuff, what you'll end up with is it'll tell you all of the slowest things that are happening in your SQL Server at the same time that all of your web tests and load tests are running. So if your database application is dying because you've got some really slow stored proc, this will just tell you what it is. It's really nice. So it's hidden, but remember that it's there. Okay. All right. So once we've got that, we can run our load test by clicking Run, and that'll execute it, and it'll simulate a bunch of users doing a bunch of stuff. And let me just change this to be a really short load test. Where's duration? Let's make this a 15-second load test. You probably wouldn't do that in real life. So you kick that off. It says in progress. You can double-click on it. Yeah, it's fine. Just keep going. And it would show you all the stuff that's happening here, what's happening inside of that test. Okay? So it would graph a whole bunch of things and show you all kinds of interesting stuff. All right. So that's creating a handful of load tests. So next up, we've created our web performance test. We've created a load test. And actually, let me show you the one that I would really run. So come back into Solution Explorer. I've got one called Website Traffic. And this has, basically the same kind of thing. It's got a combination of a bunch of traffic, and it's ready to go. So if we run it out of Visual Studio, we only can simulate 250 users max, and it only uses one core of your machine. So 250 users is pretty good, but if you want to do more than that, you really need to get into something called a load test rig. And those load test rigs help you simulate a lot of users at once. All right. So a load test rig is made up of at least two pieces. Piece number one is called the load controller. Piece number two is the load test agent. So the controller, you're going to install that on some machine. I'm usually doing it on Windows Server. And what that's going to do is the controller orchestrates what's happening in the load test. And for that controller, there's going to be one or more load test agent machine. So those agent machines are responsible for actually generating the load. So they're going to generate the HTTP requests that come off of that, and they're going to hit the application under test. So then we've got that load controller. The load controller's hanging out in the background, talking to these agents, making sure that they have stuff to do. And the controller is also going out and it's talking to all the machines that you've set up all the machines that you have perfmon counters configured for, and it's capturing those perfmon counters and logging them into a database. Okay? So the idea here is you're going to simulate an awful lot of users, and you're going to record all the data that's happening on the application under test. So your application under test might be your web server plus an application server. Maybe you've got a document server, SharePoint, database server, whatever you've got. You're going to hook up perfmon counters, and the controller is going to grab those perfmon counters off of all of those relevant machines. Okay? All right. So if you wanted to start hooking up to your controller, I'd open up a load test, and then there's this little button right here called Manage Test Controllers. Now, there's a possibility that the user interface for this is going to change before it hits RTM. This is the release candidate right now. The UI is a little unusual. So you have to remember that this is where that Manage Test Controllers button lives. So if you hit that, it's going to bring up this dialog here, Manage Test Controller, and you're going to say, what is the controller machine I'm going to connect to? Load controller 2012. And then it connects and it says, okay, well, what are the agent machines that are attached to this controller? Right here. Okay? So when you run the test, it's going to use that configuration. It's going to be able to show you what's actually going on. If we ran this, it's going to say status running test. And then we've got, right here, we've got the location, the SQL server where the controller is going to log the results. So here's a quick tip. So the load test controller needs a SQL server to log its results to. If you're testing an application that uses a SQL server, don't use the same SQL server. Okay? Reason being that if you're throwing 50,000 users at your SQL server machine and you really want to know why is this thing so slow, you don't want to have a whole lot of distractions that are coming in because the load controller is also trying to insert 50,000 records. Okay? So if you keep them separate, now they're separate, and you're not getting confusing information. Everyone that makes sense, right? Okay. Cool. How do you install the load test controllers in the agent? So you'll download an ISO, or it's an ISO. I get everything on ISOs now. Download the agents ISO from MSDN. And let me just bring up what the name of that file is. It is going to be Agents for Visual Studio 2012. So mount that, run it on the machine you want to be a controller. It'll walk you through a wizard, just next, 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 next. It's going to ask you what SQL server you want to use. So usually what I do is I install SQL Express on my controller machine, and then just use a local machine. So you got to install SQL Server first, then install the agents and the controller. It's simple. It's really simple. Just a bunch of wizards. You type in the name of the machine, and that's it. What? Do you need a special license for it? If you own Visual Studio Ultimate, you own the license to simulate as many users as you want. If you don't, you need to go buy Ultimate. Or another way that's probably not legal, you could install the evaluation version. Maybe that'll work. All right. So the next thing you're going to want to do, when you want to run your load test against the rig, instead of running it on your local machine, you're going to create what's known as a test settings file. So if you've seen these before, they sit up in solution items, and you got to create a new one. I usually call it load test rig. And inside of that, I'm going to go in and I'm going to click roles, and I'm going to change test execution to be remote execution. And then I type in the name of my controller. Okay? Once I've got that, once I've configured it, I'm going to come back to test settings. I'm going to right-click this file and say set to active test settings. So the next time you run your test, or any unit test really, it's going to push it up to that controller. The controller is going to run it there. Nothing executes on your local machine, and Visual Studio just becomes the administrator client for running that test. All right. So let's now pretend that we're going to run that test against the load test and see what happens. So we'll come in here, we'll go back to Visual Studio, right-click on that test settings and say, make this the active load test and web test settings. So if you're playing with the RC, I believe there is a bug right now. So another way that you would expect to be able to change the active test settings would be to go to the test menu and come in here and then choose the test settings you want. It doesn't work. The way to make it work is to come over here, right-click the file, say active load test settings. Okay? So that's just a bug in the RC. So now that we've got that, come in here and let's run this, and hopefully it will not die. So while that's running, so now I hopped into Manage Test Controller, and you see the status is now saying running test. If we double-click this, right now it's saying that it's initializing performance counter collection. So the controller is going out and talking to the different servers, trying to see, okay, can we capture the perfmon counters we want? And it's taking a little bit of time, a little longer than I want it to, so I think it's about to error out. So this is very picky about DNS settings. So if you ever wondered if you have DNS problems on your network, run the load test client. This is like, it's kind of like, like in drug development, like certain drugs are like, wow, this works great for epilepsy, and the people that take it lose 50 pounds a month. It's kind of the same thing here. You run the load test client, and it will find all your DNS problems. So it's actually running. Amazing. So it's saying test in progress, and we've got key indicators are showing up here. And we've got, if we drill into these counters, we will see, like let's look at memory on this machine. So we'll say percent committed, double click on that. Let's make it a little easier to read. Memory is staying pretty flat, and then we've got this other one, which is user load. So how many users are we currently running in our test? Keeps on going. And we can look at all kinds of other stuff like average page time, errors per second. There are tons of counters that are being captured right now that you can drill into. You'll also see that we're getting a lot of errors. So we're getting 40 errors or so, and if we go into this, see that the errors are 500 internal system error. So if we drill into that, let's see what's going on. Let me just stop the test so I can show you what's going. Well, you know what? I've got a screenshot of that. That'll be faster. So we're running those tests right now. And if we drill into that error message we're getting, so we're seeing that error is showing up, like right here. Here's a screenshot of that same test that I ran previously, and it's getting 119 errors by the time it's done. And it looks a little weird. Like if we look at page response time, like this graph, there's no data in weird places. If I start seeing graphs that don't have data constantly through them, that starts to say to me that there's something wrong with my app. So in this case, it basically means that the page response time was probably 0. And if we drill into what the errors are, if we clicked in here and then clicked in a bunch more times, we're going to see that this is the exception that's getting shown on the screen. So timeout expired. The timeout period elapsed prior to obtaining a connection from the pool. This may have occurred because all the pool connections were in use and max pool size was reached. So basically, when I'm trying to go get a database connection, it's dying. Anyone know what's going on? Yeah, I think you're right. So if I went to SQL Server and ran SP-who2, so SP-who2 says who's connected to my machine right now. This is what happened at my customer site. We figured out, oh, well, there's like 135 open connections, and they're all doing nothing. So basically what they had done is they were using Enterprise Library's data access block, which is really good. And as I'm talking to them, I'm like, are you guys closing your connections? They're like, we don't have to. We're using Enterprise Library data application block. So they're right and they're wrong. They're right that the data application block will clean up after itself. They're wrong in that it will clean up after itself when it gets around to it. Okay? So what was actually happening on this app is that it would, if you're running it on your local machine, the database connections are being closed when the garbage collector in .NET came through and got rid of those objects. So the garbage collector was closing the database connections. Now, the garbage collector is a very low priority process on the server and in .NET. So if you're only running one user against the application at once, it'll be fine. The garbage collector can keep up. When you run, let's say, 25 users, now the garbage collector is not as high priority, and it doesn't get around to it. It doesn't get around to closing those connections. So SQL Server runs out of connections really fast. So what you really want to do is you want to make sure you're closing those connections. So if you create a database connection, put it in a using block. So that is exactly what was going on. So what we ended up doing, we went through and we found all the places where they weren't closing their database connections, reran the load test, and we went from 20 simultaneous users to 4,000 simultaneous users. Pretty much just by closing the database connections. Yeah, it's a big deal. So afterwards, once I fixed that, now my graph looks totally different. My number of errors goes down to 2, which is not unheard of. And then our response time looks normal. We've basically found that performance problem. We recreated it, and we fixed it by just closing those database connections. Okay? All right. Any questions on the load test rig stuff before I move on to performance profiling? Yes.
I have a question about the load test rig. If it has to be in domain, because I tried to run it with local accounts.
Yep.
And I run into big problems with permissions and stuff like this.
So the question is, does a load test rig require you to run it in a domain? Does that sound right?
How I can run it without domain?
So there are a lot of permissions things you have to worry about. What I would recommend for you, if you want to run it not in a domain, you're going to have to create users with the same username and password on every box in that work group. It didn't work? Anyway, thank you very much for coming. I don't know, dude. Send me an email, and maybe I can help you out. Off the top of my head, I'm like, I got nothing. All right. Yeah, user error. I don't know. I literally have never tried it, but I can't think of.
I was asking if I need domain, if it's supposed to work or not, if I am idiot or Microsoft is idiot.
I don't work for Microsoft. I think it should work without a domain. I would expect it would work without a domain. If it doesn't work without a domain, try adding a domain. See what happens. How's that? Are you glad you came to TechEd? That's a pretty good answer. Yeah. Thank you. Thank you. I'm a fraud. I'm a fraud. All right. So moving on to performance profiling. So we've done the first 4 steps. We've reproduced the errors. We've found it was that we weren't closing our database connections. Let's pretend we went and fixed that. Okay? So let's say that our boss is really paranoid. And even though we seem to have gotten the application working pretty good, she wants this to be even faster. It's like, okay, well, now that we're doing this tuning, let's go in here and let's find performance problems in the code. Like, maybe our code is slow. Maybe we're not doing everything exactly the right way. So this is where the profiling tools come in. So where the load tests help you find issues in the system as a whole, profiling helps you find smaller problems that exist inside the code. Okay? So what I really would want to do is, the best practice is to create a unit test or a web test or a load test, something that's repeatable, that does the exact same thing the same time every time. And you're going to use that to profile your load. So right-click the web test, say create performance session, run it that way. That's the way I like to do it. Now, if you're not exactly sure where your performance problems might be, you can also do something called profiling under natural load. So what you're going to do is you're going to attach the profiling tools and just randomly click through your application and hope that you surface the issue that's in your code. Okay? So when you're using those sampling tools, there's a handful of different profiling methods. Excuse me. When you're using the profiling tools, there's a handful of different methods for how it finds issues in your code. So the demos I'm going to do today are focused on sampling. So what that's going to do is that's going to attach to your application. It's going to watch the process. And every, let's say, 10 ticks of the processor, it's going to go see what's going on in your application. And it's going to do that without making any modifications to your code at all. So it's looking, basically top down. It doesn't really know what's going on. It's just like, yeah, let's see what's happening now. And now. And how about now? So that's good for finding stuff when you don't really quite know what you're looking for. If you know what you're looking for, then you might want to switch over to instrumentation. So instrumentation will take your .NET application and inject code into the IL that will give you really detailed information about what's happening in your app. Then you've got stuff for concurrency. So if you have a multi-threaded application, tools for that. There's stuff for profiling memory. And then finally, there's stuff for profiling how your app talks to SQL Server, and that's tier interaction. But I'm going to focus on sampling today. All right. I'm going to skip over that guy. Let's go profile some stuff. All right, so I'm going to close this guy. Reset my IIS. So let me show you in my demo where we're load testing it and we've got the performance problem. Let me show you how I fix my performance problem. So we go into web config and we locate this configuration value right here that says ignore cleanup. Right now it's set to true. I'm going to set it to false. Hit save. My performance problems are fixed. Generally, this is not the way that it works when you're running in a real application. But if that is the way it works in your application, awesome. Really, that sounds fantastic. Okay. So what I would really like to be able to do, and this is another bug in the RC right now, hopefully they're going to fix this. I think they're going to fix this, is you can come to the test results of your load test, right-click on it, and then say create performance session. So what that'll do is that'll say, okay, here's the test I just ran. I want to run this exact same test again, but now I want the performance tools attached to it. So right-click, create performance session, and you get a nice exception. So it's broken right now. So there's another way to do this. So you can come into Performance Explorer, and you can say, launch Performance Wizard. Okay? Do that, and it's going to walk you through. And actually, this is a wizard that has something useful on the first page. Clearly not written by Microsoft. And it's going to say, okay, what kind of profiling method do you want to use? I'm going to choose sampling and hit next. And then it's going to say, what application do you want to profile? Okay, I want to profile my web application. Hit next. It's going to say, all right, do you want to launch any applications? Yep, we'll launch IE. And then we'll finish up, and we'll get to this point right here. We'll click Finished, and it's going to launch profiling. So hopefully this will come up in just a moment. All right, so it's saying preparing the web server for profiling. So it's basically talking to IIS, getting ready to run IE, getting ready to profile the application. This is also slower when people are not. Okay, here we go. Starts the profiler. IE should pop up in just a second. And then once IE comes up, I can start drilling through the application. And what it's going to be doing is it's going to be looking at my ASP.NET app to see what are the slow things that are happening in there. All right. Click Next. Click through some stuff. Apparently the load test created a whole lot of junk data inside of my app. And anyone ever been to Shanghai? There's a building in Shanghai that has this weird baby on the side made in plastic, and it's called Want Plaza. I'm like, all right, sure. Looks good. All right, so I've sort of simulated, I've gone through my application, I've done a bunch of stuff, exit IE, and then I'll say stop profiling. And then it provides me with this profile sampling report. So we can look through this, and there's a ton of stuff that's happening. So one of the things that I like to do is just go into the call tree, and then I got this button right here called Expand Hot Path. So this is kind of like, another thing that you could call that button is show me my performance problem. It's the easy button. So you do that, and it's like, okay, well, these two things are kind of slow. And let's say expand the hot path again. Okay, that's kind of slow. And it starts showing us places in our code where we've got some problems. So if we look at this, we'll say, okay, has cached version of the page. This is kind of slow. Right-click, go into View Source. And first off, we see some really bad stuff going on. One, someone is locking sync root, so it's making it single-threaded. That kind of sucks for performance. Then someone's doing a thread.sleep250. No apparent reason on that. And then we've got this run gratuitous loop method. That's weird. So we drill into that, and we're like, okay. So it loops for 10,000 times and calls another method. Let's drill into that guy. And we're like, okay, and that loops another 10,000 times. And what it does is it calls console write line. Well, that looks like a performance problem. So if we back out of it, let's back up the tree a little bit. So we'll come in here and let's look at the code for the source for this. Okay, so we're looking at this stuff, and yeah, that's kind of weird. And let's drill up a little bit further. And we'll see, okay, yep. Oh, conveniently enough, someone gave us a configuration value that allows us to turn that off. So let's pretend that we've just found our performance problem and it's like, wow, let's fix this. So one of the things I'm going to do is I'm just going to come in here and I'm going to turn off that value that just basically keeps it from going into that code. Like I mentioned before, this is probably not as easy in your application. Use terrible cache equals false. Perfect. So we'll come back over to our Performance Explorer, and let's run it again. So we'll start profiling. It'll come back in. It'll do that same process again. Pop up IE. We'll go through and we'll do some stuff. Come on, you can do it. And the idea here is that now that I've fixed some stuff, I'm reprofiling the application to see if I actually made an impact on the performance of my application. So we came in here, and let's go ahead and click through it. I don't know if you can tell, but this is noticeably faster already. That looks pretty good. So I'll hit close, stop profiling, and it should show me the results of this profiling session. So if we drill in, probably a good idea is to go back and look at the same call tree, and we'll expand the hot path again, and expand the hot path once more. Okay, now we have performance problems someplace else, but the original one that we were looking for, we don't see those same caching problems. Everything's a lot faster this time. And if we wanted to get really fancy, we can take the two results. So we've got the reports here that they show up under the reports folder. You highlight the two of them, right-click, and then say compare performance reports. And it will show you the comparison. And one of the things that we'll see here is that we've got the line for where we had the custom profiling, the cache manager. Now that we fixed that, the numbers are going in the right direction. Stuff is a lot faster now. Okay? So that's the quickie version of using those profiling tools. So, moving on. So we've gone through all these steps. We simulated a bunch of users doing a bunch of stuff with the load test rig. We found that performance problem with not closing up our database connections. Then we went in and we used the profiling tools to look for performance problems inside the code. We fixed the perf problems, ran the performance wizard again, verified that those performance problems were gone or at least better, and then we compared the two reports just to see, what were the actual changes. So we fixed that code. And on that note, any last questions? Perfect. So I have a couple articles on load testing with 2010. They're in Visual Studio Magazine. I'm probably going to be writing one for the 2012 release that should be coming out fairly soon. So if you want to check that out, these slides are up on my blog, benday.com/blog. There's also a video of me doing the performance demos if you want to check that out. And bunch of different resources from Microsoft if you want to check that out. Microsoft bloggers that are interested in this stuff. And that'll be it. Thank you very much for coming to TechEd.